So this is example 10 in our complex numbers topic. We've been looking at how to calculate the modulus and argument of a complex number. That is, we're trying to put it in what's called polar form. And in polar form, we have a distance from the origin, which is our modulus, and we have the angle that the number is from the x-axis, or the positive real axis, and that's our argument. Now, there's an interesting thing about the argument is that it can be expressed in a number of ways. And we've, up until now, if you've looked at the examples 8 and 9, we've really considered the kind of traditional way of trying to find an angle using the kind of 4 quadrants of our quadrant diagram. And in that case here, when we think about our real and imaginary axes, we were to think about an angle, say in the 3rd quadrant, we might think of the argument as being this angle here, positive angle, which would be an angle between 180 and 270 degrees. And that's absolutely fine. We have a way of doing that. If we work out the related acute angle, we can say that it's 180 degrees plus our angle for working in degrees. However, we can also consider the fact that there's a negative corresponding angle. We don't usually at this stage think about an angle answer being negative, because we usually give our answers as a positive value between 0 and 360 degrees, or 0 and 2 pi radians. That's what the typical response is. But in complex numbers, we can think of the argument as being the negative angle. So that kicks in when our argument is in the 3rd or the 4th quadrant. So we're going to have a look just quickly at how to make sure we can express our argument as either a positive angle in the 3rd or 4th quadrants, and also as a negative angle. So here's the example. Find 4 ways to express the argument. So there's a few ways we can think about that. So we know that actually I've represented my complex number here already, almost without knowing it. -1 minus I, if I were to put on this axis here -1 here and -1 in the imaginary dimensions, my complex number here is actually -1 minus I. Okay? Get rid of some of the other bits around it. And we're not going to worry about the modulus just now, just the argument. We know that we can say that the argument, theta, is the inverse tan of what we might call b over a, this, the real part over the imaginary part over the real part, which in this case here, we've got -1 and -1. That's a and b. So it's -1 over -1, which divides through to give us 1. Again, you might by inspection know that there's a 45 degrees kicking about from that graph, but we can tell from the theta equals the inverse tan of 1, there are 2 angles that give us a positive value, and that is, because it's tan, it's either going to be in the 1st or the 3rd quadrant, and our diagram tells us it's going to be in the 3rd quadrant. We would normally, now that we're solving a trig equation, we would work out the acute angle associated with the tan of 1, or the tan of what is equal to 1. Inverse tan of 1 would give us 45 degrees. So our acute angle is 45 degrees, or pi over 4 radians. Okay. Again, the traditional way then of solving this would be to identify that our angle is in the 3rd quadrant. And the way we get into the 3rd quadrant is by taking 180 degrees, or I'm going to start with radians here, and we're going to add on, to get into the 3rd quadrant, we add on the acute angle of pi over 4. We can think about pi as being 4 quarters, because we're dealing in quarters. 4 pi over 4 plus 1 pi over 4 is 5 pi over 4 radians. Or, if we're working in degrees, we can say that it's 180 degrees plus 45 degrees, so our argument would be 225 degrees. Okay? They are both positive arguments, one in radian measure and the other in degrees. What about the negative value? Well, up at the top of the screen here is a kind of catch-all. So this works all the time. If you know an angle around about your quadrant diagram, if you subtract 2 pi or 360 degrees, you will get the first negative value. So we could actually use that and say, or, so this is us finding the third and the fourth possible value. All we need to do is to say that our argument is 5 pi over 4 minus 2 pi. And 2 pi would be 8 pi over 4, which gives us the answer negative 3 pi over 4. And for the other one, theta is 225. The angle we already know is an answer. Subtract 360 degrees, which gives us negative 135 degrees. So those two answers are our negative arguments. And we can always subtract 2 pi or 360 from our first answer to get a negative. There is another way of working it out, and that's simply using the diagram. I quite like this method here, because on the whole we're dealing with exact values. So if you work out that the acute angle here is 45 degrees, then it stands to reason that we have a complementary angle here also of 45 degrees, because that quadrant is 90 degrees. And we know that this is 90 degrees here, which means that the angle we're actually looking for between those two sections here, 90 plus 45 is 135 degrees, going effectively the other way, going from 0 back round. And so by inspection, or by looking at the diagram, we can also say the answer is 135, or you could do the same with pi over 2 and pi over 4 added together is 3 pi over 4. Because it's going the other way, it's negative 3 pi over 4. I just want you to be aware of how we find the argument in negative form, because we are going to use that later on in our work, and it's good to be able to work with both positive and negative arguments. Okay, I'm just going to take you on and have a look at another way to do it. So now that you've got the idea of that, there's one extra little trick that we can use for this one, and I've chosen this one because when we look at the complex number root 3 minus I, there you go. Root 3 is positive, minus 1 here, or negative 1, gives us a complex number here in the fourth quadrant. Okay? And we can still do the same kind of business with the argument. We could say that it's inverse tan of b over a, which is the inverse tan of negative 1 over root 3, or negative 1 over root 3. Tan is negative, which means it must be in the second or the fourth quadrant, and that matches up. We know it's in the fourth quadrant. So we need to work out the associated acute angle. The inverse tan of positive 1 over root 3 is 30 degrees, or pi over 6. Oops. Pi over 6 or 30 degrees. And in actual fact, it's quicker to think about the negative one here, because our associated angle in the fourth quadrant is meant to be a reflection of the acute angle in the first quadrant. So what we've just said here is that the acute angle in the first quadrant would be pi over 3 radians, which means that our negative angle is the same distance or same angle in the opposite direction. So we can say here, in actual fact, that we'll just keep writing the quadrants. A fourth quadrant angle it's actually quicker to work out the negative argument by just saying that the argument is not pi over 6, but negative pi over 6. I'm not sure why I've written that in there. Negative pi over 6 or negative 30 degrees. And you can see how that's actually a whole lot easier. We could work out again, the traditional positive value. We know it's a fourth quadrant angle, which is 2 pi minus pi over 6, which is 12 pi over 6, minus 1 pi over 6, which is 11 pi over 6. And all of a sudden, that seems like a lot of work when we could just use negative pi over 6. And similarly, we could say 360 minus 30. That's not so bad. There's all the arguments. Okay, so try and make sure that you understand how to find the argument of any angle. If it's in the third or fourth quadrant, we would often express that as a negative angle. If in doubt, just take 360 degrees or 2 pi away from the angle that you can work out. Okay, on we go.